this video, we will discuss about check if a word occurs as a prefix of any word in a sentence. Given a sentence that consists of some words separated by a single space and a search word, check if search word is a prefix of any word in sentence. Return the index of the word in sentence where search word is a prefix of this word. If there is more than one word, return the index of the first minimum index, and if there is no such word, then return -1. So what they are saying is that in the input, we are given a string sentence and we are given another string which is search word. We need to find that whether any word in this particular sentence starts with this particular word or it has its prefix as this search word. If there is no such word, then we have to return -1. If there are more than one, then we need to return the minimum index, right? And that index has to be one indexed, right? So how can we do this is that first we can split this sentence into words on the basis of spaces, right? So once you will do that, you will get an array of string, right? So basically you will be having an array where the first element will be the first word, the second element will be the next word, and so on, right? So once you have got this array, what you can do, you can take the first element and compare it with the search word. So you will keep a pointer I over here and you will keep a pointer j over here and you will compare these two values. And then you will check that, okay, these are not equal and this string is finished. So then that means this word is not starting with the search word. So now let's move on to the next word. Then again, you will keep a pointer I over here and a j over here and you will see that these are not matching. Then okay, let's move forward to the next element. And like this, we can find out whether is there any word in the sentence that is starting with the search word or not, right? But here, splitting the sentence on the basis of a space and converting it into an array of strings is avoidable. So what we can do is that we can directly search this word in the sentence. There is no need of splitting it. So see, what we can do is, firstly, we can maintain two pointers I and j, I for the sentence and j for the search word, right? We know that whenever we encounter a space, then whatever is the next character, from there a new word is being started, right? So with that, we can identify that when we are considering a new word. So we can avoid splitting it into an array, right? So what we can do is, we can keep a pointer I over here, j over here, and we can compare these two characters. Then you will see that, okay, these are not equal. So then that means this word is not starting with the search word. Let's move on to the next word. So this I was here. So what you will do is that you will keep on incrementing your I until you encounter a space, and then afterwards your I should point to this first character after the space, right? So I will come here, j will come here. Again, you will check whether these two characters are equal or not. So now these two are not equal. So again, you will have to keep moving your I forward until you encounter a space, and then whatever is the next character after that space, there you should keep your I. So I would be here, again j would be here. Then you would compare, okay, e and b are not equal. So then that means this word is also not starting with the search word. Let's move on to the next word. So I would come here and j would be here, right? So if I write these, so I would be here and j would be here. Now you will see that, okay, p and b are equal. So let's check the next character, right? So I will now come here and j will come here. So now u and u, again these two are equal. So let's move I and j forward. So I will come here, j will come here. Again, r and r are equal. So we will move forward. I will come at g and j will also come at g. Again, these two characters are equal. So again, we will move forward. But now I will come at e and you will see that you have crossed the index of search word. So after this, while you were comparing these characters, if at any point j reaches to the end of the search word, then that means we have found a word which is starting with the search word. And this is that particular word, right? So what you can do is that while you were checking these words, so for the first word, you can keep a variable current word or something as 1. We can initialize it to 1. And whenever we are moving to the next word with the help of these spaces, we will increase that current word by 1. So for this, it will be 1. For love, it will be 2. For eating, it will be 3. And when you will be at burger, then it will be 4. So since now J have reached to the end of the search word, so you can return 4, which was your current word at that particular point. Otherwise, at the end, you can return a -1, right? So let's quickly look at the code of this approach. So what are we going to do is, first we will maintain a variable current word, which will denote the particular word that we are considering right now. Then we need a variable I for keeping pointer to the characters in the sentence. And then we can take a variable n to store the size of our sentence, right? Now, while our I is less than n, while we do not reach the end of the sentence, what are we going to do? We need to check whether the ith character in the sentence and the jth character in the search word are equal or not, right? And every time we are starting with a new word, we will always start j from 0, right? So we will take a variable j which will start from 0, and then while our I and j are within the range of sentence and search word, we will compare the ith character of sentence and jth character of search word. So while I is less than n and j is less than search word dot length and sentence of I is equals to search word of j. So while this is true, we will keep on incrementing I and j both, right? Once we are out of this loop, we need to check that if j has reached the end of search word, then that means we have got our answer, so we can return the current word over here, right? Otherwise, what we are going to do? So see, let us suppose that the word that you were considering was A, B, C, D, E, and the search word was AX. In this particular case, what will happen is that I will be pointing to B, and at this point you would come out of your loop because B and X would not be equal, right? So now for considering the next word for the next iteration, you need to move this I pointer to here where we are having a space, right? We need to skip all these characters, right? So what are we going to do here is that while our I is less than N, right? And sentence of I is not equals to a space, right? Till then, we will keep on incrementing our I. So what will happen is that I was at B, but with this particular loop, now our I will be pointing at this particular space, right? So every time for the next iteration, our I will be present at a particular space, right? So what we can do is that here initially, as soon as we enter into the loop, we will check that while I is less than N and the current character, that is sentence of I, is a space. So while this is true, you increment your I and you increment your current word, right? So what is happening over here is that your I would be pointing to this particular space, and when it will go into the next iteration, I will be less than N and sentence of I, that is current character, is a space, right? It is pointing to a space. So I will be incremented and current will also be incremented, right? So I will come at this Q and current will become equals to 2, which is the second word, right? And then at the end, we can return a -1. That okay, there is no word in the sentence that is starting with the search word. So let's run this now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.